If I were to revise the title of the last nugget, it would be Basic IP Addressing, the Essence of Networking. That would have been a great title, but it's too late. It's gone. Because really, in the last nugget, we saw the essence of communication from one host to another, how a host knows when to send things to its default gateway and get off of its network and all of that. So you get the real feel of addressing and how networking communicates, or how networks communicate using TCP/IP. However, there's just a lot of details, and it was almost, if you remember in the last nugget, it was almost awkward when I said, "Oh, by the way, let's pause and talk about the classes of addresses," just because it was such a good roll that we were on of like, here's how it all works, that it didn't make sense to stop and, oh, by the way, there's these details. So that's why I created this nugget, and I thought, what a great title. Basic IP addressing, filling in the gaps. You saw how it all works. It's like jumping in the Ferrari and hitting it and going, yeah, that was awesome, and you reach the finish line, and then somebody runs up and is like, oh, by the way, you needed gas to do that, in your car, and by the way, we changed the oil. Like there's all these details you never even thought about. You were just kind of like, man, my hair is blown back. That was amazing. So that's what I want to do now. I want to fill in the gaps and talk about kind of the technical details that makes everything in the last nugget happen. The first detail I want to fill in is the addressing, as in how did the network device get the address? Well, there's many different ways that it could have gotten there. One of the ways, and I would say this is probably used for servers and key devices like printers and routers. It's where you get involved and statically assign it. This is an old school picture. I think it's like Windows 95 or something that the network properties look like that. I've got Windows 7 here. Let me go to my network status. Actually, I should show you this. Go to the control panel. Windows 7 kind of hides everything. What I usually do is just type in network and jump straight to view network connections. That's what I do. But I mean, you can poke your way around and get there another way. So I've got two adapters on here. One of them is my LAN connection. That's my physical network card. The other is VirtualBox. VirtualBox, it's actually on this spiffy CBT Nuggets machine. It's a way of doing virtual machines on your computer for free. It's amazing. It's one of those VMware replacements or virtual PC replacements, because Oracle wanted to get into that mix. So ignore that. It's not a real network adapter. And what I usually do, if I'm on my computer, and this is just me because that's what I do, I say, okay, well, this is my LAN connection, 1 or something like that. Or if I know what kind of network card is in there, I'd say, this is my Intel, network card. LAN, like I put a nice, good description that makes sense to me in there, and I do that on things like servers and servers. I don't do it on my workstation too much, just because servers a lot of times will have more than one network connection. So I right-click on this guy, go to Properties. I've got all the protocols. I open the properties for TCP/IP version 4, and I see right now my recording machine is set up to obtain an IP address automatically. That's DHCP. But I could come in here and type in, I want this guy to be 172.30.100, and use an address between those ranges and put my subnet mask in and all that, give it a default. You see what I mean? I could statically do this. And the reason I would do this is for machines that I wouldn't want the IP address to change on. See, the alternative to statically typing it in, because this becomes, if you imagine this and scale it to hundreds of computers in your network, it becomes a nightmare, because you have to go around and, number one, type them all in. But what happens if a machine gets replaced and somebody forgot it and then they type in a duplicate and now you get errors across the map? I mean, static addressing does not scale to all the computers in your network. So that's just used for key devices. What most of them will use is DHCP, the Dynamic Host Configuration Protocol. And what that is where I have my switch right here, computer plugged into it. This goes to, a lot of times, a Microsoft server, like a DHCP server, where I would go in and configure a pool of addresses on here. I'm just trying to think if there's a server I can show you. Aha, I found one. Not too many people can just bust a server out of their back pocket. So this is a server that we have running here, and I went in there. And it's actually already a DHCP server. But for example, if this were a brand new server, I could come in here and say, I want to do a new scope of addresses to hand out, and I want to say this is my local network or whatever description you want to put on there. Starting, I want to hand out 172.30.100.50 all the way up to 172.30.100. We'll say 70. It says, what subnet mask do you want on there? And I'll use 255.255.255.0. And you can see, you go through and say, well, what exclusions? Is there ones that you don't want to put on there? How long should you want to hand this out for? What is the duration of the lease before the client has to give it back if they're not using it? If they are using it, they'll get to keep it. It's not like 8 days and bam, you're cut off from the network. You have the options like, do you want to give them a default gateway? It's really, it gives you the feel to where you go, okay, this is really a dynamic pool of addresses that I set up. Here's my pool. And as the computers boot, they actually send a broadcast message saying, hello, I need an IP address. And all the different devices on that network that are sharing theirs will get that message because it's a broadcast, as well as the DHCP server. And it goes, oh, well, fantastic. Let me hand you one from my pool. And you can use this for however long you've configured that lease time. So DHCP, again, I really want to emphasize it's broadcast based, because that should already be planting in your mind that, okay, this doesn't go past a router, right? This only is on the LAN and how that works. So a lot of people will do that. Now, you can set up a DHCP server on like a Microsoft server. That's what I just showed you, was Windows 2008 R2 server. But you can also use, for instance, a Cisco router can be a DHCP server. You can even buy, if your company is big enough, a dedicated appliance that all it does is DHCP services, because DHCP is so critical. If it goes down, your clients fall off the network. So DHCP allows you to configure things automatically, and then the clients are just as easy as saying, I just want to hit that bullet, which is the default of obtaining an IP address automatically. Now, it's funny. I was just like, well, how else can they get the IP address? This concept that I just underlined right there, DHCP relay, is really a CCNP level concept. They don't really talk about it much at the CCNA level, but it's funny. I'm sitting here, what are we, four nuggets into this series at this point, and I'm going, I think you guys can get this. I think with the stuff that we talked about in the series up till now, you guys would get this. Meaning, let's say you have an organization, and for now I'm just going to use routers, but I'm going to expand your mind later to a concept called VLANs. But let's say you've got a whole bunch of small offices, right? And that's a router. So I've got office. I'll just draw a switch here. Office A down here in Arizona. I've got Office B in Texas, Office C in California. So we've got, this comes down to a switch, and we've got all of our clients and all that kind of stuff. And maybe these are little insurance offices spread all around the world, and you don't really want to buy a DHCP server. You don't want to buy a server to have to plug in, because that's expensive. I mean, you got 2 people at each office. We don't want to do that. Now, if this were my environment, I would say, well, I would just make the router the DHCP server then and have it hand out the IP addresses. But just for sake of the argument, we don't want to do that. So all of these guys connect to the main router, we'll say in Michigan. And this is where your corporate network is, where you've got tons and tons of switches and servers and hundreds of users that work out of this office. And right here, you wanted to run DHCP services from a central point. Meaning, when I have a client up here that asks for an IP address, he'll come right here to the server and get it. But I want to set it up in such a way that these guys at the remote offices also can get their IP address from that server up there. Well, that's a problem. Why? Who can follow why that's a problem? It's all right here. DHCP is based on broadcast. This guy boots up. He's like, I don't have an IP address. Hello, network. Can somebody help me out? Give me an IP address. And what do routers do? That's the sound of a broadcast dying, if you were curious. The broadcast is stopped right there. It does not go any further unless you enable a service. And the reason I want to bring it up is it's everywhere. You see DHCP relay all over the place. So I want you guys to know this at least exists. You can go into your router right here, if it's a Cisco router, and enable DHCP relay, which takes a broadcast message if it's a DHCP request. It's not all, broadcasts happen all the time. It would be a mess if it was all of them. It says, I'm going to look for DHCP requests, and I'm going to send that, take that, it's a DHCP broadcast, and I'm going to package it as a unicast, put all the source and destination headers that we've talked about on there, and send it directly to the DHCP server. And the DHCP server can say, oh, okay, well, I've got an IP address for you, and let me hand it right back down. Well, the reason they call it DHCP relay, there's the key word, it actually hands it to the router, and the router responds to the client as if it was giving it its an IP address, which is amazing because I can then centralize all my DHCP services at one spot, or in a really high-priced cluster of servers that maybe are very redundant and all of that. So that is one example of DHCP relay, but once we explore different technologies, especially VLANs, I'm going to show you, man, there's so much more that DHCP relay can be used for on that side of things. So that is another way that somebody could get an IP address. Last one is multiple IP addresses. There are times, mainly on servers, where you might want to have something to have multiple IP addresses or even multi-homed addresses. Meaning, maybe I've got, and again, without fully discussing VLANs, this concept gets a little tough, but maybe I've got two different portions of my network at the office. This is our central office. Sorry, it's getting messy. And maybe this is the public portion of my office where it's kind of like the lobby. I've got public Wi-Fi and all that kind of stuff, and then I've got the private portion of my office, and they're two different switches connected to two different interfaces on a router. They're two different networks. Well, what I can do is I can plug in an interface, two interfaces on that server, and give it an IP address in each one of those networks, and now that is considered a multi-homed server. That's multi-homing. But you can also give a server two IP addresses within the same network. Maybe you're running an email server on here on one IP address, and you want a totally different IP address for handling website. You run a website. So all you have to do, and you can even do this on a computer if you wanted to. I'll go into the network adapter, same kind of place, and you know that I can specify my IP address. This will be my primary IP address that I use for everything right there. But if I want to, I can go into the advanced and add in as many secondary addresses I want to. Oh, by the way, this guy's also such and such. Oh, and by the way, this guy's also whatever. You see what I'm doing here. I can go in and add all these different IP addresses that this guy can speak from. Now, there's only one primary, as in when this guy initiates traffic, it's always going to come from this IP address. However, it will also respond if it gets a request on any of these other IP addresses that I want to give it. So I can go in and assign a device multiple IP addresses, no problem. Okay, let's talk about IP addressing now. Specifically, public versus private addresses and the other special addresses that exist out there. Think of the internet. Most people just think of it as like, surfing the web, or like a picture of a cloud comes to mind. But really, the internet is a network of networks. It's the biggest network in the world. That is just one network attached to another, attached to another. It started with some college universities wanting to tie together. They called it the ARPANET. And before long, people are on there buying T-shirts and everything else that you can get online, and books and whatnot. So we have this gigantic network of networks where everything's combined. So everything that's connected to the internet needs a unique IP address. So, here's your computer at home. We always draw it as like a cloud, but really there's a router there of your ISP, and they have to temporarily give you, and they do it via DHCP, unless you pay them for a static IP address. They'll give you an IP address that allows you to access the internet as long as you are staying connected, and as long as your device is powered on and actively running. And you are consuming one of the 4,200,000,000 million addresses that exist in the world today. They're in the IPv4 address space. There is actually, hang on, let me pull it up. There we go. I got it. It's 4,294,967,294 IP addresses. And you can Google that. You don't have to know it or write it down. So 4 billion some addresses that are there. Now, it sounds like, wow, it's a lot of IP addresses. But then you start realizing that we have ultra bazillion network devices out there that if every network device in the world got its own public IP address on the internet, we would long since have run out. Like it just wouldn't work. I mean, you think of yourself. You have a cell phone that is connected to the internet. You have multiple computers at home, at work, a laptop. You know, I probably have. I'm just looking around my office right now. I see a couple printers. I see a router. I see some switches. I have 1, 2, 3, 4 computers surrounding me that are actively on and being used. I have my iPhone. I have some IP phones sitting on my desk that are online. So I mean, it's just, and I'm one man, Jeremy Chara. I have all of this stuff, so it's just not scalable. So they came up with this idea of private IP addresses that allows people to assign addresses that are not usable on the internet. Now, there's a lot of misnomers about that I want to demystify, but let me first off talk about the way this works. What you can do is inside of your company or inside of your house or whatever environment you're in. Let's go with a house because that's nice and simple, and then you just exchange bedrooms for cubicles and you have an office environment. You've got your house, which I just described in my house. I've got 4 computers just surrounding me. You've got a Wii. You've got all of the different things that exist there. Maybe you have 20 network devices in your house, which I would say is probably about average nowadays. So what you can do is just make up IP addresses in your house. You go ahead, and if you're like 90% of the homes around the world, you're probably using 192.168.0. something addresses inside of there, or .1. something addresses. And the reason I would know that is because every Netgear, D-Link, no-name device that you go buy and plug in at your house hands out these addresses via DHCP by default. Now, your house uses those addresses. Your neighbor's house uses those addresses. Their neighbor's house uses those addresses, and yet there's no problem. How does that work? I mean, I told you every single network device has to have its own IP address. So how does my computer have the same IP address as my neighbor's computer and nobody's screaming? Well, the way it works is through a system of NAT. Let's say I've got a router. These are routers at the corner of my house that is plugged into Cox or Quest or whatever ISP, whatever carrier you're using to connect to the internet. This device runs something called NAT, Network Address Translation, which allows you to take all of these IP addresses. It could be 20, it could be 200. It could be 2,000 IP addresses, and now you would definitely outdo me, maybe, if you had 2,000. But 2,000, and it would actually translate it, or some people call it overloading, or some other people call it PAT. There's many different names for it. And we'll totally unpack this one later. Translate it to one public IP address that your internet service provider lets you use. So maybe they give you the public address of 5.5.5.5. Essentially, anything not shown here or in these ranges down here are considered public addresses. So 5.5.5.5, what my router will do is allow all of these 20 devices to share and be hidden and pretend to be that one IP address. And again, I'll show you how all that works later on. But my neighbor, they might get 5.5.5.6. So their 20 devices are never seen because they're using duplicate addresses, and they all go out as this one address. So private addresses are not only useful in houses, they're also useful inside of organizations as well. When you're in a large company, pick Boeing or Intel or Nabisco making Fig Newtons. You've got large manufacturing plants. You can use private addressing all throughout your company because that works a-okay. It's just once you want to get to the internet will block those addresses from being used, so you have to NAT them out. So private addressing. It's kind of like, think of it this way. You remember when what was that movie? 1980s. There was a movie called, I just remember Christian Slater was in it. Oh, Pump Up the Volume, where he ran his own little pirate radio station out of his dorm room. And in the end, he ends up getting busted because the FCC comes in and is like, you can't run a radio station because those are restricted frequencies. We manage all the frequencies. Think of that as like, that's the public IP addresses. You can't just go out there and start saying, I want these, I want those, because they probably belong to somebody else in the world. However, the FCC has granted broadcast privileges on some frequencies, which probably sound familiar to you, like 900 megahertz, or 2.4 gigahertz, or 5 gigahertz frequency spectrum. What are those? Well, those are used for like cordless phones or wireless Wi-Fi devices inside of a network. The reason they call these unmanaged or unlicensed frequencies is because they're like, hey, you can run whatever you want as long as you're not maliciously trying to destroy somebody, somebody else trying to use those frequencies with it. And they put some restrictions of the power you can use and all that. But otherwise, anytime we bought a cordless phone or a new wireless network widget for our house, we'd have to go register that with the FCC. Think of these as like your unregistered, your unmanaged IP addresses that you can use wherever you want inside of your organization. You don't have to register or pay for them at all. They're free for all. So that's awesome because it lets us set up our networks for free without well, besides all the Cisco gear we have to buy, but I mean, we don't have to think about buying IP addresses for our network. Now you drop down here, we have automatic addressing. This is a special range of addresses, 169.254, that a computer will sometimes, depends on what features that computer has, but sometimes will generate if it can't contact a DHCP server. So let's look back at that picture. Or I'll just bring it up here. This computer is set to get an IP address automatically. Right, so it doesn't have one at all. So when it's booting up, it's let's say it's sitting here in this house right here. It's broadcasting. It's like hello, 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 hello. I need an IP address. It's sending these broadcast messages like mad to try and get one. But if there's no DHCP server out here, nothing ever comes back, and that computer goes, well, what do I use? What it will do is it will just pick something from that range. If it's a Windows, and again, this feature can be turned on and off, but it'll just say, well, I guess I'll be 169.254.50.22. Now, it's smart enough to actually send out a little beacon saying, hey, is anyone else out there 169.254.20.52? If it doesn't hear back, it goes, oh, okay, that's the IP address that I'm going to use. So usually, if you see this address, something bad has happened because you don't usually want to see those. But what that allows you to do is kind of build your own little local area network. You won't be able to get on the internet with it, but your own little local area network if things break down or you just don't want to think about DHCP. Loopback addressing. When the inventors of TCP/IP thought of it, they thought, we want to dedicate this massive range of addresses for testing, for testing connectivity. So they took, 4 million, just millions of addresses that actually 16 million addresses that are in this range right here, and they said we're going to use those for testing, but really people ended up using only one of them. 127.0.0.1. If you go to any device in the world that is on a network and do a ping 127.0.0.1, you'll always get a response back as long as the device is actually has a network card inside of it. That is considered a loopback address. It's an internal test that it uses to, just does a little kind of cycle saying, okay, am I a valid network adapter? Do I have TCP/IP enabled? So 16 million addresses reserved right there, and we use one. And so that's the one that we use for loopback testing. The last one I say special addresses, and I mentioned this in the last nugget, but I want to specifically bring it up here. The first and last IP address of a network or a subnet, and I shouldn't have said subnet, it just came out. The last or first IP address of a network are the network and broadcast. So if I were to say 172.30.100.0, or that's the network we've been using with this subnet mask. I go, okay, well, this is my network and this is my host, and I know that these IP addresses can go 0 to what's the biggest number? 255. You got it. So the very first address, the .0 can't be used because it represents the network. It identifies it. You see it inside of a routing table of a router. The last IP address also cannot be used. I can't assign it to something because that's considered the broadcast address. So if I wanted to send a broadcast to everybody in that network, I would send it to 172.30.100.255, and that would reach everybody inside of that network. Now keep in mind, it's not always as simple. I know it's easy when you're at this level to just be like, okay, anytime I see 0 or 255, that's bad. I won't use those. I can't assign those. Well, be careful. I mean, we're using this because it's the most common subnet mask in the world, but there are others. Let's say I did 172.30.0.0 with this subnet mask. It's actually known as a Class B subnet mask. Now I'm saying this represents my network, and this represents my host. By the way, that actually gives me 65,536 hosts that I can have in that range. Now, if you just hard-code it in your mind and you go, okay, 0 is bad and 255 is bad, well, then you're going to have a lot of bad in that range that aren't really bad. There's only one bad, or one that you can't use, and that's 0.0 and 255.255. This is the network, and this is the broadcast. Did I say there's only one bad? Well, only... two addresses, one of each that you can't use. But also remember, as you start counting, the way this is going to increment, it's going to go 0, 1, 2, 3, 4, 5, 6, 7, 8, 20, 30, 40, 50, all the way up to the point where it gets to 255, and then it's going to flip this over. Now we're at 1.0, and 1.1, 1.2, 1.3, 1.255, and 2.0. You see how it keeps going up. So I could take the IP address 172.30.2.255, and I could assign that to a PC. Whoa. Weird, man. And if you're used to just seeing this and going, oh, that's bad, or just seeing this, oh, a 0, that's bad, then you're going to miss a whole lot of IP addresses in that range, because there's 3.0, there's 3.255, there's 4.0, and they're all valid because, remember, in every single network, there is only one network, and there is only one broadcast address. Everything in that squishy Oreo center middle is totally usable. Okay, last thing I want to talk about here, last gap that I want to fill in, is the classes of addresses and some of the terms like classful and classless and kind of everything along those lines. Even some of the different kinds of messages that we can have when we're communicating using these IP addresses. So when the creators of TCP/IP invented it, they came up with 3 standard classes of addresses that exist. Class A, B, and C. And just by looking at an IP address, I could throw one out there, 12.5.6.2. Just by looking at that, I could go, oh, that's a Class A. I know that because you look at that first digit right there, and if it's between 1 and 127, it's considered a Class A. Or if that first digit is, let's say it's 172.30.100.30, that's what kind of been our mascot through this series, I would go, oh, first digit is a 172. That is a Class B address. So it's real easy just by looking at the first digit of the address to be able to identify what kind of address it is. But that's only half helpful because it's like, well, what does that do for me? What are the difference? Well, the difference is the default subnet mask that these addresses have. Class A addresses have the default subnet mask 255.0.0.0. Or a shorthand way to write that, and I will fully explain this syntax later, it's a /8. Class B, the default subnet mask is 255.255.0.0. Or a shorthand way of writing that is /16. Class C that's the most famous one. 255.255.255.0 or a /24 is shorthand for that. So, rather than every single time somebody putting, 255, a lot of times they'll just go /24, and people go, oh, that's a Class C address and what that is. So, or, you're quickly able to identify the subnet mask. So, this was considered the class full addressing of the old days. Meaning, if you applied this subnet mask to these addresses, let's just grab one. Let's say 10.0.0.0, and its class full state has the subnet mask 255.0.0.0. What that means is I actually have one network. It's the 10 network. So everything that starts with the number 10 is considered on my network. And all of these octets are used for the hosts. What that gives you is 16,777,214 usable hosts on that network. It actually gives you 216 addresses, but you remember the very first one and the very last one can't be used. So we have 214 usable hosts. Now, initially you're like, oh, wow, well, that's a big network. Well, it's just not possible. It's not reasonable. You can't have a network that big. What that means is you've got a switch with, or multiple switches. I mean, sure, give it the benefit of the doubt. We can daisy chain multiple switches, right? But you've got multiple switches with 16,777,214 hosts, computers, devices plugged into that one network. There's no routers in between them. Doesn't work. Why? Broadcasts. Broadcasts will flood the network. I mean, Cisco, I would say just a guideline, and this, I wouldn't even say this is documented, but kind of a rule of thumb. You should never have a network above, again, guideline-ish, I would say 500 devices at most. And that's pushing it. I mean, it's rare that I see a network more than 200 devices that before we have some kind of routed boundary in mind to kind of keep the broadcast traffic down. But I would say with modern processors and all that, modern network technology, you could probably get to 500 devices and not see too much impact on performance. But remember, each device that you add to that network has its own broadcast that it's sending. It's saying, hello, everybody. I mean, your booting devices, they're sending out traffic, all that kind of stuff. So the more and more you add, the more and more these devices have to receive and process all of the traffic from all their brothers that they don't even care about. They're just dropping it. They have to look at it. They have to see what it is, but they're like, oh, it's not really for me. I'm going to end up dropping that traffic. So a network of 500 devices is really big. So you look at this and you go, okay, we overshot that by 16 million some addresses. So that it's just not scalable. So what did they have in mind when they created these monster networks? Well, they had in mind that, while we can use the class full version and it will work, we can use those subnet masks. They had in mind that people will use something called classless addressing. All classless means is that yes, we have all of these classes of IP addresses, and we have the default, the class full subnet mask that the standard of TCP/IP said we should use, but I don't want to use that. I want to put a class C subnet mask on my class A network. And now you can see why this one becomes the most popular subnet mask in the world. It's because what that does is say, okay, well now I've got the 10.0.0 network. There's my subnet mask. And I've got one octet for hosts, which gives me 254 usable host addresses. There's actually 256 that it gives you, 0 through 255, but you can't use two of them. So 254 usable host addresses, and that's a good, reasonable amount. So what you see all over the place is people applying Class C subnet masks to all kinds of different addresses inside of their network, all kinds of different networks. But I mean, what this does is give you a ton more networks that you can have. I can have the 10.0.0.0. 10.00, 10.0.1, 10.0.2. I mean, just a ton of different networks with little pockets of 200 some hosts. This goes 0 through 255 on each one of those networks that I can use wherever I want to in my network. I could start assigning those to different offices. So I can have, corporate up here, which is 10.0.0, and that has a connection over here to our Arizona office, and they use 10.0.1. I mean, we start assigning these to different networks all around our organization, and each one of those networks support 254 usable IP addresses inside of them. So that's the different classes of addresses that exist, and at least what subnet mask they start with, but I can change that. Now, you're never supposed to go backwards. For example, I could and this is actually, by the way, considered subnetting when you apply a different subnet mask than what the standard allows. But you're not supposed to go backwards. I'm not supposed to say 192.168.0.0 with a class B subnet mask on it. You're supposed to only go further, not pull back. However, I've seen, I just started managing a network where somebody used 192.0.0.0. With they put a Class A subnet mask on this Class C network, and it worked. I mean, I had to go to therapy to handle that network, but at the same time, it worked. So while you're not supposed to, in this classless world, you can do. Wow, that's almost two different meanings though. In the classless world that we live in, you can do almost anything that you want. So what about these other ones? Class D and Class E are untouchable. Like we don't, unless you have a very specific reason like multicasting, you don't use those in your organization. So let me fill in. What are the different kinds of communication that exists? There's unicast, multicast, and broadcast. Broadcast, we know, is one message to everybody. Unicast, we know, is one message to one device. It's single device communication. Multicast is the one in the middle. It is one message to a group of devices. This is, by the way, the future of communication. We're going to see a lot more of this as time goes forward, but just to give you an example, things that would be very useful for this is like internet radio or imaging. For example, let's take imaging. Some of you may do this in your organization where you have a server, you have all these PCs, maybe you've got hundreds of PCs, where instead of going and installing Windows on each one of those PCs by hand, you create a master image. And you send that to all the PCs, so they all have the same look, the same feel. You don't have to manually install Windows. I mean, imaging, like Acronis is imaging, Norton Ghost is imaging. These are applications that do it. So I set up a server which sends an operating system, like an actual operating system image on there. If I use broadcast to do that, it's a mess because he sent one message to every computer, just throttling the network with all this traffic because he's sending a full-blown operating system. I mean, he fills up a hard drive essentially with the amount of data that he sends. So he floods the whole network, and our whole network would probably go down until that guy stopped broadcasting because he's sending so much data. If I did unicast, which is valid, but each computer that I add to the image stream slows it down because he starts off maybe imaging at gigabit speed to this guy, and then I add another computer, and now he has to divide it because he's sending one stream to him, one stream to him. So each person gets 500, and now we divide it again. Each person gets 333. Divided again, each person gets 250. So it gets slower and slower and slower the more devices you add to it at the same time. Thus, multicast is born. What multicast does is assign. Think of multicast like a radio frequency. Like you tune into a radio frequency in the car. What will happen is these guys get assigned a radio frequency multicast address. Let's just say 225.1.5.32. I just made that up. They all actually get assigned that same address, which, whoa, that's weird right there, right? Because we're used to things all having their own IP address. But in multicasting, they all tune it. I mean, don't think of it as being assigned an address. They all tune into that frequency. So the server starts broadcasting, sorry, I can't say that. The server starts sending to that IP address or broadcasting on that frequency is what I was trying to say. But really, it's just sending one stream to that frequency, that address right there. And all the computers tuned into it get it. The ones that aren't tuned in don't. So they don't get throttled like a broadcast would and pummel the network. So multicast can be really handy for doing things like that. The final one is experimental. That's why I brought our little scientist onto the scene. This was just a whole chunk of addresses that when they created, they're like, we want this to like embed in lab rats and things like that. We definitely can't use or touch those address ranges. Whew, a lot of gaps to fill in, right? So what did we see? And more importantly, what do I want you to do with this information? What we saw was how a device gets an address, whether it's static, dynamic, multiple addresses, even multi-homing, connecting it to two different networks. We saw public and private addressing, where each would be used and what those ranges were. Along with the classes of addresses, we saw class-full versus classless networking, even types of communication, unicast, multicast, broadcast. I mean, just a lot of, and this is just kind of like a mega fact nugget, filling in a lot of that information. So what do you do with this? Well, It depends on if you're studying for the exam. I would highly suggest, and I wouldn't even focus this for the exam. If you want to be in networking, how about that? I would highly suggest memorizing. There is going to be some memorization, those private ranges. Be able to see an address and be like, I know exactly what private address, if that's private or public, and if you just see an address, you should know what range it came from. Thankfully, you can focus your efforts on just class A, B, and C. Just remember those ranges and where those are at, along with what subnet mask each one of those classes have, and understand that concept, because we'll see it again of class full using the default subnet mask versus classless IP addressing. So all of those, just, that's brute memorization. Get those things embedded in your head using whatever method you'd like to. Then I'd like you to go on your device, whether it's at home or in the office, and pull open a command prompt. Do an IP config. Identify. What network am I on? What kind of class of network? Am I using class full or classless addressing? This I'm looking at is classless, because this is a class B address right here with a class C subnet mask on it. So identify those kind of things. Start thinking about what other IP addresses would be in the same network as me. Find out, am I using DHCP? Well, how do I know that? Just looking. Hey, come back. Just looking at that address, how do I know? Well, you can do an ipconfig /all, and that will tell you not only if you're DHCP, which I can find out looking up here, but also what DHCP server gave you that IP address. In my network, I use the router as the DHCP server. I don't rely on a Windows server where I come from. I can even see some information like what DNS servers I have. Those servers resolve the name to IP address. So when I type in Google, I actually send a message to this server saying, well, who is Google? And this server comes back and says, well, this is who Google is. Start playing around with ipconfig. I know it's a Cisco world that we're talking about here, but Cisco does require you for the exam to know some of these commands like ipconfig renew or release. So I can say, well, I want to get rid of my IP address. Whoops. And we just lost network connection. So I just like that, I kicked off my IP address, lost all network connectivity. I can come in there and say, well, let's do an ipconfig again. Notice, ooh, look at that. See, look at all this action I'm having to do. I mean, do this. Try this on your own device. It says, well, if I'm not going to use the DHCP address, then I'm going to make up one. Remember those 169.254 addresses. I can say, well, I'd rather be connected to the network, so I'll do an ipconfig /renew to get my please to get my IP address back, and now I can use it again. So again, play around with those, experiment, see what you're using in your network, so that this becomes real to you. I hope this has been informative, and I'd like to thank you for viewing.